All right, good evening, everyone. In this session, we'll be beginning science and technology. In the previous sessions, we were looking at economic survey, but I've taken a detour just to prioritize what is more important for prelims. The other chapters and the concepts in economic survey will take a secondary priority. My primary methodology for current affairs would be to prioritize high yielding areas. So in today's session, we'll be approaching this in two different halves. In the first half, what I'll be doing is I'll be focusing on how UPSC designs questions in prelims and what are the various categories of topics that you have to check and figure out how to derive patterns from that and what information to focus on. This is the way in which you have to check the prelims info. And then once this prelims concepts are out of your place, you will have to focus on what will come in the mains part, which we will be looking at it. Thank you. So, in order of priority, what are the areas of importance we'll be looking at, and then how UPSC designs questions. So let us look at them one by one. The first type of questions that you can get is about the classification of a technology. In 2025, you have seen this question, right? All drones are of this category, all drones are of that category. That kind of a question is there, right? So where will this come up? This will come up in the classification type of a thing. When you have a technology, it will try to address certain issues. Different categories of, let's say for example, you're taking UAV. These unmanned aerial vehicles are of different kinds and each of that kind will serve a specific problem. Always look at science and tech questions as a tool to solve a problem in the society. And this simple funda is tested by UPSC in multiple ways. Multiple pathways will be created. So one is the technology and its kinds will have different purposes. So UPSC will test whether you are aware of that classification of the technology. Let's say for example, whenever you see a news item, let's say anything that appears in the category of let's say seeds. Just a example I'm telling. If you are looking at a seed, what most people will end up doing if you are preparing current affairs is you will by heart the fact and that event. What you should actually do is observe how that headline is actually tagged to a specific problem statement. How science is used to solve that problem. Science doesn't change. Like sun rises in the east or every action has an equal and opposite reaction. All of these are established facts. What do we do with it? That's technology. This is knowledge, this is wisdom. Technology is application of knowledge. So we are interested in seeing how you are trying to pick up the knowledge part and apply it to solve a social problem. This method is tested in multiple ways. One is the classification, second is the mechanism. When you are saying mechanism, there is a effect produced by this technology. There would be a cause for that effect too, right? This cause-effect relation is nothing but the mechanism. Understand the why. Let's say for example, if you're talking about rare earth minerals, which is in news right now, you need to know why they are important in your mobile screens, for example. How battery components will work in different ways. Like if you're looking at a system, the process becomes important. Now again, when you're talking about the process, individual components and their respective role in that system is enough. You don't have to get into the nitty-gritties. That is not what UPSC is expecting from you. Next, third level of question is about the scope. When you're talking about the scope, you will see some absolutist statements, extreme worded statements, or some traps. Let's say today, if I tell you that artificial intelligence can, and I use the word can find cancer cure, it is only showing a probability. Can you definitely say it cannot? No. If I told you that artificial intelligence ChatGPT created the next cancer drug and cancer is no longer existing in the world, it's an absolutist statement. You are establishing a probability as a fact. So, when a possibility is shown as a certainty, it is expanding the scope. Okay? When 50% is possible, you are showing it as 100%. You have to identify that statements. In order to be able to identify those statements, you should know the mechanism of how that works. Clear? And if you understand the mechanism, you should also understand why categories of that particular technology exist. Okay? Next up. Usually you will see that UPSC changes the name of the organizations where the scientific innovations take place. This is an old pattern. It's very likely that UPSC will change this pattern this time. But whenever you are looking at a organization in news, be careful from now on. Usually people used to think that when an organization name is given, it is automatically false, because that was the pattern till now. UPSC can pretty much change that, and let's say, for example, if there is any institutional name mentioned in current affairs, they will definitely retain the correct name. It's a possibility. So whatever you find in current affair magazines or news, especially with this institution names, be careful this year. This can be a pattern shift. Clear? Now, finally, the most important and the most easiest one is when you understand the mechanism here, any false generalization made on that mechanism can easily be eliminated. In your science and technology options, I want you to first identify this in the multi-statement questions or the options. Eliminate the false generalization. So here also you will see absolutist statements. Clear? In short, if you have multiple statements, statement 1, 2, 3, 4, you simply have to know what mechanism can UPSC use to make the statement false. If you can catch that logic, UPSC, the science and technology part will be very easy. This is the various kinds of question that you can find in the prelims exam, depending on the option design. I'm not even started with content. I'm just talking about how to approach the subject. First, understand the challenge that you're facing and then move forward. Fine. All of this, maybe most of you will know. I'll tell you one more fact. And again, this is based on historical observation. Whenever you're talking about history, polity, geography, or all the conventional subjects which are not considered to be dynamic, you will notice that the answer, let's say for example, if the options are like A, 1, 2, 1, 3, 1, 2, 3, D, none. See, this is just an observation in subjects like history, polity, geography, and economy, the traditional subjects. In these subjects, UPSC expects that you are very, very precise. So, most likely the answer will be either in A or B or D. It is historically observed that the option C, which tries to include maximum number of statements to be true, did not exist in the subjects. You can go back and check. Why is this? This is because UPSC expects you to be very precise in the statements. Like once I create the statements, statement number 1, statement number 2, statement number 3. UPSC expects, because the syllabus is limited, the number of books that you prepare, like the scope from which UPSC creates questions. For example, history. There is no new topic that will come. Same Indian national movement will be asked in different formats. So if I have to confuse the aspirant, I will have to go extremely precise or use the same fact in a different way. Like I will give you some clues so that you are aware of the context as well as the clue, and you use that to say statement number 1 is right or statement number 1 is wrong. Okay, you take a decision based on the very narrow range of facts. So these subjects will move towards an option that will have an answer with as minimum number of option statements as possible. So this is just a pattern. It is not truth. It is not a trick. I'm just giving you a pattern that we observed. This I call it as, let's say for example, moving towards minimal options. Historically, it is the opposite when it comes to science and tech and environment as topics. Again, we are only talking about the patterns part. Why is this the case in science and tech and environment? Because this is extremely dynamic. If I create a statement which is supposed to be false, it becomes very difficult for a non-science background student to know that fact. So let's say for example, if I start becoming very specific in biotechnology and go into the specifics of genome editing, someone from the genetics background, doctors or biology background, they will have an edge, and UPSC doesn't want that. What is the intent here? It is to see if you understand the mechanism properly or not. So it started creating very simple, straightforward, basic questions. And as a result, answers always used to be all the above. All the statements looked very much possible. So what happened? YouTubers and some people picked up this trend and started propagating that whenever you see science and tech, any question, put all the above. UPSC is watching all of this. So now there will be one, this pattern already occurred. UPSC will design a statement in such a way that at least one option will be false. So the answer will be between 3 statements right or 2 statements right if completely new topic is coming. So the remaining 2 statements will be either from news or from previous year questions. Clear? Same is the logic for environment too. Considering how vast this topic of science and tech is, we will have to rely on first previous year questions, 2 the basic concepts of every technology that is coming up in news and previous year questions. If anything comes beyond this, not just you, everyone else will make it wrong. While we are covering these technologies, what I will be doing is, I will be picking up information from NCERTs, clubbing at them at the appropriate places and delivering them together as a package. Clear? This is the methodology for science and technology. First, we are decoding the pattern as well as the design of question. And we are seeing how across time period the question paper evolved. And why people were giving advices like this if you see science and tech all the above. And why we should be very careful of these patterns from now on. Once you understand these patterns, now You will no longer have the FOMO that you don't know the tricks and circus tricks that people resort to. Without a logic, without an anchor, if you just rely on these techniques, UPSC paper will become like a circus. You don't want to do that. And if you don't know this, you will again go back into the trap of memorizing a lot of content. So we're trying to create a balance. Now that you know everything that other people in the competition will be knowing, we will now focus on what other people will ignore. What is that? Technical precision. To the extent that it will empower you to mark the right answer. Clear? And I will be prioritizing those news items which I think will have higher probability this year in the order of the news items, like the probability of a specific issue appearing in news. I have a slight headache today, so I'll probably cut down the session and cover it up in the next class. So I'll pick up a few technologies and I will tell you how to cover them in the prelims context. Let's begin. Okay, before we begin, what are the domains that I will be covering in this series? You need to have a clarity, right? So these are the areas. Energy and power. Why? Energy Atmanirbharta as a concept. Energy, like generating electricity and supplying fuel, is necessary for economic growth, especially in the context of AI, which requires humongous power. India needs to figure out its power sources, the technologies therein, and ensure that it is sustainable. In this context, I will be listing down all the possible technologies involved in power production, distribution, and how to figure out where we should be heading towards, depending on what resources we have. That is area number 1. Then, usually you will see that technical precision depends on understanding how sensors work. If you want to measure something, what is the fundamental assumption in science? Science is supposed to follow and obey what data shows. How will you capture data? By developing the right kinds of sensors and ensuring they are not faulty. So sensors and measurement is the second area of interest for me. Then materials and manufacturing. Here you are going to talk about mines and minerals, the developments in the metallurgical and material technology. Then we will be talking about how they will actually address the problems in various sectors like aerospace, defense. Then we'll be moving towards the trending topic, computing and AI systems. So here we are going to talk about the software aspects. The software that is responsible for Industrial Revolution 4.0. We spoke about IR 4.0 in multiple contexts. We will see what they are again in the subsequent classes. Then we are looking at biotechnology, bioprocesses. Please focus on the process part here, because questions will be picked up from that process only. One of the step in that process and the technology that can catalyze and bring efficiency in that process. And then health technology. While you are preparing these concepts, whatever news items that are relevant from the Hindu, Indian Express, PIB, and any other article that you will find in the market will be clubbed together within that domain only. And that will address all your current affair problems in a single structure. When you have this kind of a structured approach for current affairs, the margin for error will be absolutely zero in science and tech. It should be zero because you are not going for a wild guess anymore. You either know the principle or you know the pattern and the technology. You also know the fact that is there in current affairs. The margin for error therefore will be zero. I can understand if it's history. I can understand if it is polity. You might make some errors based on memory. An error in science and tech is unacceptable, especially when it's very predictable. If it is coming from a core NCRT JE level kind of a question, I will still excuse you. But if it is not the case, error in this area is unacceptable. Finally, we will be moving towards space and strategic technology. We'll be looking at the evolution. Let's say we'll begin with the basics of orbits, let's say. Then we will see what are the various kinds of tools to access space. Nothing but the space tech. Then we'll be looking at various international organizations that are involved in this space race, namely ISRO, NASA, JAXA, European Space Agency, so on and so forth, even China's systems. And then we will also look at the GPS systems, like basically navigation systems. All of this will be in the block of space and strategic tech. Apart from this, you also have something called frontier technologies, namely the evolving technologies that can disrupt the functioning of the world. Can you name a few? Which is already mentioned here. Quantum computing, nanotechnology. Nanotechnology can be placed under this material technology, for example. Okay, so there are some other areas like this which will be clubbing and putting them under respective blocks. Let's say, for example, you might say, where are we going to put blockchain? Here. Clear? Any development, any fact, any principle, all of them will fall under the respective chapters. And before that, I will be simply taking up some small issues which I think are of highest priority this year, just to get you into the zone of science and tech syllabus. The objective here is not to give you randomized facts, but just to display the pedagogy that I want to deliver and I want you to adapt, so that you don't get any question wrong. When you give me your undivided attention for science and tech within the class, you will be finishing that syllabus here and here itself. Clear? Next. So yeah, this part we already discussed. Now moving to the most important area, according to me, you have a Nobel Prize for a specific technology this year. And I'm not interested in teaching the physics or chemistry behind it, because that's not how UPSC asks, at least till now. If that pattern changes and they're expecting you to become scientists, we'll see that next year. But going by the data, we will just focus on how UPSC is asking questions. The first news is about the metal organic frameworks. MOF. Remember this word and the fact that it was given a Nobel Prize in chemistry. So this specific innovation or discovery rather has path-breaking applications in multiple areas which can solve world problems. Let's understand what they are. But I don't want to go into the specifics of the technology directly. Let me begin by showcasing the problem that we are dealing with. If you are a bureaucrat or a politician, do you really think you would be interested in a scientific article if it is not helping their cause? If you want to win an election, you would want to care about the scientific discovery. Let's say, for example, do you think politicians would have cared, or bureaucrats or politicians would have cared, if vaccine was not promised during COVID? They would have cared, because their survival is also at stake, not just the world's. Any scientific discovery without any immediate social impact will always take a backseat. It might be celebrated in the scientific community, but for it to become a socially viral content, at least in today's world, that's what I would want to call it. If it were to become viral and common knowledge, it should solve a very specific problem. How many of you knew this company called AstraZeneca before COVID? None of us. Most likely. Pfizer, AstraZeneca, Bharat Biotech. Nobody knew these companies. I know this would be very inappropriate and insensitive to say, but they got permanent PR with one event or one dark phase of human history. It's a crisis for majority of the world, but an opportunity for one section of the society. So, why am I telling you all this? Even UPSC aspirants are no different. If you were given this news and I told you that this is very important, you will be like, great. You will probably put a like on Instagram and move forward, but you will not care to open what it is and understand it. With that intent, let me tell you what problem it can solve. So the problem statement we are dealing with is carbon dioxide, greenhouse gases. Today we are reaching almost the limit of what Earth can tolerate. So we are looking at every probable solution to address this pain point. In that context, this can be helpful. Remember that. Next. What else can we solve through this? Atmospheric water harvesting. What do you mean by this? Take a look at this. Desert regions often possess significant atmospheric humidity, but you don't have water there. Using this technology, you can give water. So it's like saying that I can produce water out of thin air. Literally now. Next up, clean energy storage. You have solar panels. What is the problem? Once the sun sets, I don't know what to do with this panel. It is useless in the night. It can be used when I can harness that solar energy created and store it in a battery. But the problem is batteries are very expensive. How can I make batteries cheaper and efficient? That is also one area this MOFs can be extremely significant. That's why we are reading this. Okay. What else? Wherever there is a possibility of an industrial disaster, immediately to address that specific concern, you can use that. Or if there is a continuous discharge of effluents or discharge of harmful gases from a factory, we can use this technology to contain them at the spot. We can use this technology for that. Precision chemistry. What do you mean by this? Some chemical reactions require very specific narrow range of conditions to be created in a setup for that reaction to be performed. This technology will empower the laboratories to create that environment. Clear? These are the things that you need to know. Now, let me ask you a question. In which of the following, okay, I'll rather start again. Recently, a discovery on metal organic frameworks was awarded the Nobel Prize for Chemistry. In this context, which of the following use cases illustrates its best application? 1, 2, 3, 4, 1 only, 2 only, 3 only, all the above. This kind of a question can be possible. Do you know what is MOF? You still don't know what is MOF. Can you answer this question? Pretty much possible. This is how UPSC will create questions. If you think you are smart, UPSC might outsmart us. So we will go one step ahead and actually know what is MOF. Let's go back. So, what is this MOF? You need to know the basic crystal solid state chemistry basically. Again, I will not try to include a lot of jargon. I will try to simplify things for you. Just read what I'm saying. 1 gram of this can possess an internal surface area equivalent to multiple football fields, allowing it to capture more number of molecules. If you are curious, you will become a scientist. If you want to stop here, good, you will become a UPSC aspirant. How, why, where? To explain this, it took them a lifetime, and that's why they got a Nobel Prize in Chemistry. So if you respect their skill and respect your limitation, you will stop here. If you think you are much more curious, you are free to go ahead. But I'll also tell you how it is possible briefly. Or I will not say how, I'll just say what you should be remembering. So when there is a certain arrangement of internal structure of a certain material in a way that it will accommodate what was physically impossible before, what was considered to be physically impossible before, that kind of a framework is called this MOF, which will enlarge the area that it can be so huge that it can be absorbing all this CO2. That's all you need to know. It's an arrangement of material in such a way that transcends the existing physical boundaries. If you know this much, it's enough. Moving forward, chemical selectivity. This is one more point that you need to focus. They can be chemically engineered. Please focus on this. It is created to selectively attract CO2 over other gases, ensuring efficient and targeted capture. So this technology is going to be a huge breakthrough for an industry that is coming up. Carbon capture industry. The future billionaires would probably come from the arena of billionaires, or I don't know, even trillionaires will come from the arena where they will supply clean air, fresh water, clean food, or whatever was basic 200 years ago. These basic things probably can become luxury. 150, 200 years from now, clean air will pretty much be a luxury if we continue with a business as usual approach. In order to be that trillionaire, you might want to perfect the use cases of this MOF. And because of this monumentary discovery, I believe that UPSC should pick up this topic. But again, whether it will follow the T+2 cycle or pick up current affairs from the last 2 years, or whether it will pick up directly from this year, we are not sure. But I think this is very important for the reasons that we just discovered, and that's why I'm giving this. Next up, telescopes in Ladakh. Again, the budget recently announced the extension of funds for new telescopes. What is the purpose of a telescope? It's like an object that will move from 720p to 4K resolution, just like an equivalent. If you have a YouTube video that you are looking at in 720p and then 4K resolution, you will instantly notice the nitty-gritties and nuances of that video, right? Telescope is nothing but a device that will empower you to do the same thing, but not on a screen, into the space. And they are designed for different purposes depending on what wavelength they are capturing or what wavelength they are looking at. Now, to make sense of this word wavelength and what they are capturing, I will have to take a step back, explain the basics of electromagnetic spectrum. Electromagnetic spectrum is referring to a huge spectrum, like a arrangement, an imaginary line you can imagine. If I arrange different frequencies on this line and there is a law which explains this. The energy of a certain wave is either a function of its frequency or wavelength. Simply put, if this is the frequency part, the number of waves, highs and lows in a specific range, you see, it means that there is high frequency when compared to here 1, 2, 3, 4, 5, 6, 7. You see 7 highs. So in this case, frequency is 7. In this case, you only see 3. Frequency is 3. So if you want to deliver a packet of energy to a very short distance, you will have to have higher frequency. If you want to deliver it to a very long distance, you will need to have wavelength. That's why it is inversely proportional. Clear? Electromagnetic spectrum refers to an arrangement of various energies on an imaginary scale, and in that imaginary scale, one spectrum, one part of it is very important for us, which is called the visible spectrum. Whatever you see around us today, the corresponding color has a certain frequency, and in that 400 to 700 nanometer range itself, all the colors that we see around us will make it possible for us to feel that color. Our eyes are capable of capturing only in this range. Now, just because we do not have the tools to observe anything here or here, to the left or to the right, doesn't mean they don't exist. It is our inability to not look at them. So here is where these telescopes come into the picture. Let's say, for example, if you have a injury to your leg, you will carry a crutch. It doesn't mean that you don't have a leg. It is just an impairment temporarily. Similarly, just because you are looking at a technology for observing something in the sky, doesn't mean that if you stop looking at it, they will vanish. Clear? Why is it important to have these telescopes all the time in the space? Anyone? See, I'll just give you an analogy to remember. Why is it important for us to always point our telescopes into the sky? I'll just give you a simple analogy. If you are looking at a satellite orbiting a planet, you will predict exactly when it will appear at what time. As opposed to a foreign body or a celestial body which can appear at any given random time. It will not announce itself like, I'm coming, please look at me. It's like state PSC notification. You don't know when they'll come. You just have to keep on looking and hope that it will appear in your lifetime. And sometimes if your luck is bad, you might be blinking at that time. It will pass away. As opposed to that, if you look at a body that is orbiting a planet, it is pretty much predictable. It's like UPSC notification. So we can afford to blink because there will be someone else looking at it and they'll be pointing at us. India cannot afford to stay back because you can't expect information to be shared when it is that rare. And if you want to have an edge in the scientific community, you will have to develop the capabilities to capture that. Clear? And it is in this context we will be understanding the telescopes and the budget given to that in the present budget. So before that, where would you like to put these telescopes? So whenever you have doubts like this, imagine you are spending a bomb on your probably saving up entire salary of yours and going on a trip to North Pole to capture that aurora borealis, the green lights. Just when you're about to capture that photo, someone will come into the picture and look at it, and the aurora borealis vanishes. Would you be pissed or not? Right. In a similar way, you will have to understand the implication of the question here. You would want absolutely no disturbance in an area where this telescope is placed. Why? You do not want it to be contaminated by another light. Light is ultimately energy on the visible spectrum. And these, you might say, like, of course, these telescopes are not designed for visible light, right? Then why should we be worrying? There is a possibility of interference. There is another concept. And we don't want distortion in our line of view. So we will be putting them at an altitude where human beings don't usually stay. And we'll be putting them where the skies are very clear. And we will be pointing them towards very specific targets, because they are meant to solve a very specific problem. With this understanding, let us have a look at it. The Union budget sanctioned 2 world-class telescopes in Ladakh. Why Ladakh? It's one of the highest areas from the mean sea level in India. And this will qualify for all the criteria that we discussed. No photobombing here. So, what are the telescopes? Solar telescope, large solar telescope. Why not a normal solar? It is the quantum of data you can capture. The large size is attributed to the quantum of data it can capture at a given moment. Now, large optical near infrared telescope. What do you mean by near infrared? It is another frequency. Is it less than or more than visible spectrum? Okay. So, if you don't know the basics of electromagnetic spectrum, please go back and refer to that 8th standard physics. Clear? Fine. Now, what problems are this telescope solving? Let us understand. First one, solar storms and satellite safety. Imagine you saved a lot of money and invested in stock market trading. Everything depends on microseconds. And as if someone is, plotting a revenge against you, there is a solar storm that will create a temporary blackout, which will lead to a massive loss. Your stock market earnings can sometimes be subject to not just market risk, but also atmospheric risk. So to prevent that, this is just one attempt to say, not to stop the solar storm. Don't get confused. We do not have that kind of technology yet. It is just to say, see, there is a possibility of a solar storm, and if you want to risk it, please go ahead. Next, observing gap in the optical near infrared region. So what is it trying to say? There is a existing capacity, but that is not enough to capture high definition. It's like an upgrade from 720p to 4K resolution. That's all you need to remember. Next. Next is data sovereignty and time zone coverage. When you don't have the domestic facilities, you will always have to store this data elsewhere, which will defy the very purpose of our investment here. If we want to have an edge in the scientific community, we have to produce it as well as store it locally. That's why. Now, there are certain conditions given in newspapers regarding the importance of these sites. High altitude, dry, cold desert, low light pollution, and the presence of Indian Astronomical Observatory. Okay, these are the reasons cited. That's why you will have to note them down. So here I'm giving you a comparison of the various telescopes. When do you want to use a radio telescope? Okay. In order to be able to answer this, you need to know where radio waves are there on the electromagnetic spectrum. Less or more than visible light? Much lesser. Much to the left of, you know. So in this case, what will happen? You will use this radio waves in telecommunication. You used to use them in telecommunication. Now with the advent of 5G, we are moving to the right of the spectrum for efficiency. So you want to carry higher packets of energy, so you will require larger infrastructure. That is why 5G infrastructure, 6G infrastructure, the high speed internet will cost much more because it will require multiple delivery men. At this point of time, we don't have the capability to carry more than a certain weight. Let's say if I have to carry within a specific time from here till high-tech city 100 kgs of weight, I can only go to high-tech city. But if they say that I want to deliver it to maybe some other town, I will hand it over to the next person in that high-tech city and ask them to go forward. The people that we are talking about in this case is nothing but the transponders or the infrastructure elements in the 5G, which will carry these packets of energy. Okay. So these electromagnetic spectrum and the understanding behind it will make this point very easy and clear to understand. I'm expecting a question here, but if you are still confused and if you want a heuristic mechanism to reduce your risk, this is how you should look at it. If there is a mention of a space weather, most likely you will have to use solar telescope. If there are exoplanets, infrared. Hydrogen clouds, radio. Dust covered star formation, infrared. No atmospheric distortion, again space telescope. So just a heuristic quick fix for revision. Alright, now one last item that I want to discuss is the battery system. Usually a simple battery system works like this. I know it is very mind-boggling for non-science students, so let me create an alternative simpler version. Imagine a battery to be a place where you are delivering simple, what would I say, energy from one place to another. So wherever energy is originating, that's called anode. It's like the warehouse. Last year you got a question, graphite is an anode. Other metals are cathode. So if graphite, which is the warehouse which stores energy, gives its customers a delivery. The customers are cathodes, which are usually metals. You need a road for that, right? That road is nothing but the electrolyte. Why are we creating all these analogies? To understand how a battery works. Simply put, battery is nothing but a system which is closed under which energy is moving. There is a continuous charge and discharge, just like your battery phones. Clear? So that storage is possible because of the electrolyte within them or the road. Equally, all the components are important. In the present context, why are we discussing this battery system? You already know energy storage is a huge problem. And whatever battery technology we are depending on today is based on lithium ion. We don't have that. Continuously, you will be dependent on a lot of critical minerals, namely lithium, cobalt, which are required for the functioning of this. You see in this system, you will require a wire. That wire is supposed to be made of copper. Copper is very expensive. The other alternative is aluminium. If you use aluminium, it will react. Graphite and aluminium might react and create alloys. So it is not useful. All these are problems or limitations which will have strategic implications for geopolitics in international relations. We will have to continuously depend on China or any other country in the future because we don't have those mineral resources. Now, what if we can create a battery technology through something that is dirt cheap, something that is used by Gandhiji also to trigger a national movement? Salt, sodium. The same technology which was patented by Reliance Industries almost 4 years ago. Now we are at an inflection point where we will have to decide whether we want to move in the direction of sodium or not. All the limitations that I mentioned can be overcome by working on the efficiency of this sodium battery. And that's why you will see questions on this. What other areas you will have to focus when you are discussing batteries? The raw materials and their sources. Questions have already been asked. For example, if you want to focus on lithium ion battery, cobalt, which is a major component, what is the source? Congo. Questions like this have been discussed multiple times. Even in the other class, when I was discussing mines and minerals, I spoke about certain mines in African region, Shinkolo Bay, Bayano Bay. All these places can be asked in prelims exam. Like, you have to be able to identify them. Okay. So that's it from my end. Today we'll again catch up in the next class and take over from where we left here. Thank you.